Hello, this is Mrs. Brown, and today we're going to talk about solving equations when there's a variable on both sides. Now remember, when we're solving equations, we're trying to get the variable alone on one side. So I want to get x all by itself, but I have x's on both sides of the equation. Well, that's a problem. I got to get them all to one side or the other side. It doesn't matter which way I move it, I need to get them all over to one side. So I've got to figure out how to move this x or this x. Well, since there's something else on this side, it would make the most sense to move this x, and then I'll have a number equals x's. So how do I move a minus x? Well, first of all, remember that this is like a 1 when you don't have a coefficient listed, that's like negative 1x or a minus x. Well, if I had a problem like, say, let's not use x, like n minus 2 equals 7, how would I solve it? I'd add 2 to both sides because it's a minus. I'd do the opposite. Well, the same is actually going to be true when I'm dealing with variables. I have a minus 1x. Well, the opposite of subtracting an x is adding an x. And because these are opposites, they're going to cancel. Negative 1 plus 1 is going to be 0. So they're opposites. They cancel out. But now I can add an x to this side. And again, it's like 1x because there isn't a coefficient listed. So negative x plus x is nothing. I'm left with 24. If I have 5 xylophones and I add another xylophone, I end up with 6 xylophones. So 5x plus x is 6x. Now I have all my x's to one side and it's down to a one-step equation. So the opposite of multiplying by 6 is dividing by 6. I'm allowed to do that because of the division property of equality. 6 divided by 6 is 1. 1 times x is x equals 24 divided by 6 is 4. So x equals 4. So again, I'm going to move variables from side to side just like I move normally when I move numbers. So a minus x, I'm going to add to both sides. So if I have a plus x, I'm going to subtract from both sides. So let's take a look at another example. Okay. If I have 8x plus 10 equals 35 plus 3x. Now, in this case, I've got a number and a variable on both sides. I'm going to have to move one of them, but I also have constant numbers that are without variables on both sides. So I can move either one. When I'm deciding, I like to move the one that has the smaller coefficient if they're both positive, so that when I move it, my answer is still, my coefficient is still positive. You can move either of them, but in this case, if I were choosing it, I'd subtract 3x from both sides. If I subtracted 8x from both sides, I'd still get the right answer, but you tend to make more mistakes when you're dealing with negatives, so if I can keep it positive, it makes it easier. Plus, when I get to inequalities, if I have a negative coefficient, there's flipping involved and all this stuff, so it just makes it easier if I can just move it this way to keep this positive. So I'm going to start by subtracting 3x from both sides because this is a plus 3x. And how do I get rid of plus? I subtract. So I'm going to subtract 3x from both sides. Those are opposites, so they go away. And again, I'm just doing 8 minus 3. I'm subtracting the coefficients because the variables are the same. So 8 minus 3 is 5, so it's 5x. So 8 xylophones minus 3 xylophones is 5 xylophones. So 5x plus 10 equals 35. Once you've gotten all the variables to one side, in this case, all the x's, it's just a regular two-step equation in this case. So what do I do if I'm trying to get x by itself? Well, I've got a 5 times and a plus 10. I'm going to get rid of the plus 10 first by subtracting 10. 5 times mystery number equals 25. The opposite of multiplying by 5 is dividing by 5. And so x is just going to equal 5. Again, I'm using that same process. It's like solving equations that I've been practicing all along. I just need to be able to move it so that all the x's are on one side. So let's take a look at another example. Okay. All right. In this case, I've got a minus 3r plus 1 equals 15r minus 8. All right. So again, I can move either the minus 3r or the positive 15r. Doesn't matter, I should get the same answer the same way if I follow the procedure. But if I'm choosing which one I'm going to move, I'm going to move this one so that this stays positive. If I subtract 15 from both sides, I'm going to have a negative coefficient. Because this is minus, the opposite, I would add 3 to both sides, I'm going to get a positive coefficient. So again, if I wanted to move the 15, because this is positive, I would subtract 15. Because this is negative, I have to add it to move it. So I'm going to add 3r to both sides because that's the opposite. Negative 3r plus 3r is 0. I'm left with just a 1 over here. 15 plus 3 is 18. So I have 18 times r, and I still have this minus 8. Now I have a two-step equation. What am I going to do? I'm going to add 8 to both sides. It's the opposite of subtracting 8. Okay, if I have negative 8 plus 8 is going to be 0 because they're opposites. So now I'm left with 18 times mystery number equals 9. Well, how do I solve multiplication? I divide. Well, you notice that the number 9 is smaller than the number 18. Okay, so I'm going to have a fraction that's less than 1. 18 divided by 18 is 1. So I'm left with just r. And then 9/18, I can either divide it out in a decimal, but a lot of times in algebra it's easier to have it as a fraction. And so this is simplifiable. It simplifies down to 1/2 because both 9 and 18 are divisible by 9. So my final answer would be r equals 1/2. Let's look at one more type of example where I might have more than just 2 of a variable. So what do I do in that case? So let's say I had 7 plus 4n minus 13n equals 3n plus 1. How am I going to solve it? Well, don't panic. But remember that when things are on the same side of the equal sign, like this, I can combine like terms first. So 4n minus 13n is negative 9n. And I can do that before I do any of my going back and forth. Remember, if it's on the same side and I'm putting it together, I'm not using inverse operations. I'm just doing what it says. So I'm just combining those like terms. I still have a 7 there, and I still have the 3n plus 1. Now, could I have added 13 to both sides and then subtracted 4n? Absolutely. But it's usually easier to combine it and then start doing your inverse operations. So kind of do what you can and then go to inverse operations. Now, again, I can choose what I want to do for this problem. I can either move the 9n to this side or the 3n to this side. This is a minus 9n. So if I'm going to move it, I'm going to add 9 to 3, and I'm going to end up with a positive 12. Or if I move the positive 3n, the opposite of plus 3n, a positive 3n is minus, I'd subtract, and I'd end up with negative 12. Again, me personally, I'm going to move the 9 so that I end up with a positive coefficient, the number that I'm multiplying by the variable. So negative 9 plus 9n is going to be nothing because they're opposites. And then I'm going to add 9n to both sides. 3 plus 9 is 12n. So I'm left with 7 equals 12n plus 1. Now, again, what am I going to do? I'm going to move that 1. It's just a regular. I get rid of addition before I deal with multiplication. So I'm going to subtract 1 from both sides. I get 6 equals 12 times n. Opposite of multiplying by 12 is dividing by 12. And like the last example, I have what's going to be less than 1. It's going to be a fraction. And since 6 goes into both of those, it is going to simplify to 1/2. I hope this helps, and have a fabulous day.